Hello world and welcome to another deep learning tutorial. Today's topic is deep learning and neural nets. My name is Harris and let's get started. For more content on tutorials, please hit the subscribe button or leave a like or comment there. What are the pros of deep learning? It's basically reducing the feature engineering, which is the most time consumption part. No feature selection is required therefore, and it has pretty high accuracy. You can apply it to very complex problems, and the architecture you can adapt to new problems. The cons are it requires a large amount of data, and it's extremely computationally expensive to train, which means you need GPU power, for example. You do not have in the way of strong theoretical foundation, and what is learned is not easy to comprehend, which you will see afterwards. Sometimes neural nets are kind of some black box. So what are the comparisons? Machine learning and deep learning. Machine learning, you basically just choose the data and then select the features, then train the model, and then you have your output. Deep learning has another approach, therefore you have the data, you are applying a model, and the model is doing basically everything, and then you receive output. Deep learning. So you have basically artificial intelligence, and machine learning is a subset of artificial intelligence. Deep learning is itself subcategory of machine learning. Neural nets are basically used for deep learning. Therefore you have input and output, and in between you have the hidden layers, hidden layer 1 and hidden layer 2, and the neurons itself, which are connected to each other. Then if you have on the left side the x, so the output, and you want to derive y, the output, and you basically have here for also two hidden layers, and then you have on the button you have the bias input or the bias neurons, and you basically can imagine it like a offset, and you have also the weights in between and the activation function. If you see deeply inside, if you have the input layer or the x, you have here for two x inputs, and it's only an array. Let's say you have a bias, which is only the offset. Then you multiply it with the weights, which here for they are 0.5. You have the three hidden nodes, and then you have the hidden layer in between, which you multiply with the sigmoid function, which is in between of 0 and 1. You multiply it with weights, which you derive after some epochs, and then you have an output layer. Then the output is only in between 0 and 1 again. So the weights is in this case a matrix. If you see the maths, then you can imagine it's like the function which you want to derive. The y is the activation function. You have a bias. This is the offset, which you sum up with sum of x and w. W are the weights, n is the number of inputs or the incoming layers, and then you can derive basically the output. Therefore you need the nonlinear activation functions. We already covered sigmoid activation function. You have the hyperbolic tangent. You have the rectifier linear unit or ReLU, the leaky ReLU, or exponential linear unit. The ReLU is mostly used, but as well also the sigmoid function for classification, for example. For adjusting the weights, you can use the stochastic gradient descending, which is approach where you can see here the curved line. You can imagine a ball which is like just rolling down until the weight is so low that also the loss is the lowest in this case, or the cost function itself. The optimizer are using to train the neural nets. You can also adjust the learning rates, and herefore you have the SGD or the RMS prop, the ADAM or the NADAM optimizers. Mostly we will use ADEM or NADEM in the next tutorials. And you can see because of a lot of epochs, the loss will go down. So yeah, thanks for watching, and if you like the content, please hit the subscribe button. Thanks a lot and see you soon.